We'll discuss about the limit of the function which forms indeterminate form of the type 1 raised to infinity. Now we have limit x tending to 0, 1 plus x raised to 1 by x. When x is tending to 0, the base tends to 1 and power will tend to infinity. Same way, when x tends to infinity, the function will be 1 plus 1 by x raised to x. Both of them, the value of this limit is an irrational number, that is your e. So whenever we have base becomes 1 and power becomes infinity, we need to apply this formula. Basically, you will notice that this is of the form base is a function of x, power is also a function of x, and x is tending to a, the base should tend to f of a should tend to 1 and g of x should tend to infinity. Then we shall apply g of a should tend to infinity. Then we shall apply this formula limit x tending to 0, 1 plus x raised to 1 by x, or x tending to infinity 1 plus 1 by x raised to x. Both the answers are same because we know that when x tends to infinity 1 by x tends to 0 and both remains the same function. So let's see how to apply this formula. First of all, first condition to be satisfied is first term in the bracket should be 1. The second term should tend to 0. First term in the bracket should be 1. Second term should be tend to 0. And third condition is the base and the power. The second term is reciprocal of the index. If I have x here, 1 by x. If I have 1 by x here, x here. These are the conditions to be satisfied. Second term is reciprocal of index, or index is reciprocal of second term. So if I have a function of this kind, limit x tending to 0, 1 plus sine x raised to cosec x. Check when the first condition is satisfied. First term in the bracket should be 1, is satisfied. When I apply the limit, sin x will tend to 0, sin x will tend to 0, so the second term tends to 0. Second term and the index should be reciprocal. You know cosec x is 1 by x, 1 by sin x. So they are reciprocal of each other, hence your answer is E. So whenever these three conditions are satisfied, the answer of the limit will be E. Now let's have a look at this one. Limit x tending to 0, 1 plus 2x raised to 1 by x. First term is 1, second term is tending to 0. When I apply the limit, second term is tending to 0. But second term and the power are not reciprocal of each other. What does it mean? Second term is 2x. The power should have been 1 by 2x. But I have only 1 by x. So what I'll do is, I will make it a 1 plus 2x raised to 1 by 2x. I put a 2 extra and compensate it with a 2 as a power. Now, this limit will go inside, hence the bracket will be here. Now, what you see inside the bracket is E and the power 2 will remain, so your answer becomes E square. So, you have seen that all the three conditions are satisfied here. First term is 1, second term is tending to 0, second term and the power are reciprocal, hence inside the bracket is E, but there's a square there, hence it make it E square. This is how we apply this formula. Let's have a look at one more problem. Limit x tending to 0, 3 plus 2x upon 3 minus x raised to 1 by x. Now what you'll notice is, numerator also there is a function, denominator also a function. But the first term in the bracket should be 1. So to have first term in the bracket 1, I will divide numerator and denominator by 3. So 1 plus 2x by 3 divided by 1 minus x by 3. Every term I have divided by 3. Now I will separate the numerator, limit x tending to 0, 1 plus 2x by 3 raised to 1 by x, divided by limit x tending to 0, 1 minus x by 3 raised to 1 by x. Now what can I do? I need to have, first term is 1, second term and the power should be reciprocal, second term here is minus x by 3, that should be reciprocal. So I will write this as limit extending to 0, 1 plus 2x by 3 raised to 3 by 2x. I have put what extra number here? I had only 1 by x. 3 by 2 is extra, so 2 by 3 divided by limit extending to 0, 1 minus x by 3. Reciprocal of minus x by is minus 3 by x. The extra number I have put here is minus 1 by 3. So my answer became e raised to 2 by 3 upon e raised to minus 1 by 3. So e raised to 2 by 3 plus 1 by 3, hence my answer turns to be e. When you add the powers, it become 1, so answer turns to be. Now let's look at a shortcut. Have you seen the coefficient here? 2 by 3, that becomes your e's power. What is the coefficient here? Minus 1 by 3, that becomes e's power. So my conclusion, if it is limit extending to 0, 1 plus x raised to 1 by x, directly answer is C. If limit extending to 0, 1 plus kx and 1 by x only here, the coefficient of x is missing here, then your answer will be e raised to k. So you may use this as a direct shortcut method to calculate it. So looking at itself, you can say this answer is e raised to 2 by 3 and this answer is e raised to minus 1 by 3. So you can calculate it fast. So let's look at one more problem. Let's say limit extending to 0, 1 plus, 4 plus 5x upon 4 minus 5x raised to 1 by x. Now this time we want to calculate it directly. First you will divide by 4. You have to bring 1. Without 1 it will not work. So 5x by 4 divided by 1 minus 5 by 4x raised to 1 by x. So now if you take this much numerator, we can apply this formula. The coefficient of x is 5 by 4. So e raised to 5 by 4 divided by coefficient of x is minus 5 by 4. So e raised to minus 5 by 4. So e raised to 5 by 4 plus 5 by 4. So e raised to 10 by 4, which is e raised to 5 by 2. You can calculate it directly. This way you can proceed. So whenever we have, remember one thing, the x and 1 by x. Then whatever the coefficient, that will be e's power. A function of this kind, how we will apply directly, the shortcut I am going to derive for it, using the same formula, limit extending to 0, 1 plus x raised to 1 by x equal to e. You have seen that I need 1 in the first term, so I will bring a 1 by adding 1 and subtracting 1. Next, what I require is a reciprocal. So I'm going to bring a reciprocal, limit extending to a, 1 plus f of x minus 1 raised to 1 upon f of x minus 1, the whole raised to, there is already a g of x and there is a f of x minus 1 which I have divided and multiplied. Now this turned to be e. So your answer became e raised to limit extending to a, f of x minus 1 into g of x. So this is going to be my shortcut to calculate the limit of the function. And here I will be able to apply the L'Hopital's rule, derivative method can be applied. So whenever base and power both are x and the base becomes 1 and power becomes infinity, that is it becomes in the form 1 raised to infinity, this should become in the form 1 raised to infinity, that is substitution. In such case, we can directly write this as e raised to the power minus 1 into the base minus 1 into the power, and you need to take the limit of only this and that becomes my answer. So there will be always an e present in any function of this kind. So we will learn some few problems. This is my direct formula. So this formula should be remembered. What is my direct formula? Limit extending to a, f of x raised to g of x will be directly, we can use this formula and calculate, provided it is of the form 1 raised to infinity. If it is in the form 1 raised to infinity, directly apply this formula and get the answer. Let's practice few problems on this. When x is tending to infinity, this will tend to 1 because coefficient of x here is 3. Coefficient of x here is 3. So 3 by 3. So this will tend to 1 and this will tend to infinity. Hence it is of the form 1 raised to infinity. Hence we can apply directly e raised to limit extends to infinity, whatever the limit as it is. 3x minus 4 upon 3x plus 2 minus 1, that is base subtracted 1 into x plus 1 upon 3. This would be my answer. Now let me calculate this. Limit x tending to infinity. When I take the LCM here, 3x minus 4 minus 3x plus 2 divided by 3x plus 2 into x plus 1 upon 3. So this 3x will get cancelled. So e raised to limit x tends to infinity. So minus 6 into x plus 1 divided by 3 into 3x plus 2. Now I can calculate this limit directly because x is tending to infinity. The degrees are equal. So directly my answer is e raised to 6 by 3. The coefficient of x 1, coefficient of x 3. Hence my answer is e raised to minus 2 by 3. So I can calculate directly e raised to minus 2 by 3. So this is an easy method of doing the problem. Once again, whenever base and power we have functions of x, base tends to 1 and power tends to infinity, then directly we apply the formula e raised to whatever the limit as it is, e's power becomes the limit. This base minus 1 into the power, no more, not raised to the power, multiplied by the power. Then we simplify and get the answer. So this part will become any algebraic limit which we have done before. So this part exponential will be converted to algebraic by using this technique. Base will be exponential only, but the power is calculated by using the algebraic technique. Apply the limit 0, 0, the base becomes 1. When you apply the limit 1 by sine 1 by 0, so infinity. So this is of the form 1 raised to infinity. Hence I can write e raised to limit extending to 0, 1 plus tan x upon 1 plus sin x minus 1 into cosec x. So you have seen it's multiplied by cosec x. So e raised to limit extending to 0. When you take the LCM, you will get 1 plus tan x minus 1 minus sin x divided by 1 plus sin x into 1 by sin x. Cosec x I have written as 1 by sin x. So that became e raised to limit extending to 0. So tan x minus sin x. So tan x minus sin x I can write sin x upon cos x minus sin x divided by 1 plus sin x into 1 by sin x, which can be written as e raised to limit extending to 0. Sin x will get cancelled. So 1 minus cos x upon cos x into 1 plus sin x. Now, what we can do further? Now, if I apply the limit, here become cos 0 1, sin 0 0. So denominator is 1 and numerator is 1 minus 1. So 1 minus cos 0 divided by 1 into 1 plus 0. So denominator is not becoming 0, only numerator becomes 0. So e raised to 0 and so answer is 1. When n is tending to infinity, this will tend to 0. Cos 0 is 1. And when n tends to infinity, 1 raised to infinity. So this is of the form indeterminate form is 1 raised to infinity. Once it's 1 tends to infinity, we can apply this formula. Cos of x by n minus 1 into n. Now I have seen the formula limit theta tending to 0, 1 minus cos theta upon theta square is half, or if there is a k here, k square by 2. So I will bring it into that category. N tends to infinity, the angle is tending to 0, so it comes to the same category. I need a minus to be removed outside, limit n tends to infinity. To interchange this position, 1 minus cos x by n, this n will come to denominator, but I need n square. Remember, this is like 1 by n is like theta, but I need theta square. So I will divide and multiply with 1 more n, 1 minus cos by x by n upon 1 by n square. What did I put extra is compensated. This became e raised to x square by 2. E raised to x square by 2. 1 by n is your theta. X is a coefficient, so x square by 2. But this term will become 0. Hence your answer is e raised to 0 and answer turns to be 1. Confused? Looking at this is a function f of x, this is g of x. So we should apply the previous method. But just have a look at it. what is the function to the value which this is tending to? Degree is equal, so this will tend to 3. The base is tending to 3. And the power is, again, the coefficient of x is 6. Coefficient of x here is 3. It is 6 by 3. Hence, it is not of the form 1 raised to infinity. So you are not going to apply here e raised to f of x minus 1 into g of x. Here we need to directly take the value because this is not of the form 1 raised to infinity. If it is of the form 1 raised to infinity, then only you need to apply the method which I have taught you before. So the answer here will be, once again I'll explain, coefficient of x square, x is tending to infinity, so the base is tending to 3 by 1 and the power is tending to 6 by 3, so it is 3 square and answer is 9. Interesting problem. When I put x as 0, you will get 1 raised to 0 plus 2 raised to 0 plus etc. n raised to 0. That is 1 plus 1 plus n times. So this will become n. So numerator become n. N upon n is 1 and this is of the form 1 raised to infinity. Hence, we can apply the formula that I have taught you. So my formula for this will be e raised to limit x tending to 0, 1 raised to x, 2 raised to x, 3 raised to x, plus n raised to x minus 1 upon n minus 1 into 1 by x, which I can write as e raised to limit x tending to 0, 1 raised to x plus 2 raised to x plus 3 raised to x goes on n raised to x minus n upon n into 1 by x. This x I will bring it over here, nx. Now I know this is of the form limit x tending to 0, a raised to x minus 1 upon x is log a. I can apply this formula. So this became e raised to limit x tending to 0, 1 raised to x minus 1 upon x, 2 raised to x minus 1 upon x, 3 raised to x minus 1 upon x, and goes on n raised to x minus 1 upon x. That is, this n is nothing but 1 plus 1 plus 1 n times 1 plus 1 plus n times. Each of this 1 is distributed with each of these x terms. So your answer now, there will be a 1 by n over here, this extra 1 by n. So e raised to log 1 plus log 2 plus log 3 goes on like that, log n into 1 by n. This can be written as e raised to 1 by n log of 1 into 2 into 3 into etc. n. That became e raised to 1 by n into log n factorial. That became e raised to log, this 1 by n becomes the power n factorial raised to 1 by n. Now e and log can be cancelled and answer is n factorial raised to 1 by n. This will be my final answer. Now we come to the limit of logarithmic function. Let's calculate limit x tending to 0, log of 1 plus x upon x. This is nothing but limit x tending to 0, log of, 1 by x into log of 1 plus x. This is nothing but limit x tending to 0, log of 1 plus x raised to 1 by x. And this happened to be e. So you are having as log e as answer, which is 1. So you don't have to do this whole process. This is just for understanding I have done. Directly I can write, I'm removing this. Directly from this I can conclude limit x tending to 0, log of 1 plus x upon x is 1. I don't have to do this process. Don't try to do this process when log is there. Log is there, just remember this limit formula. Log of 1 plus x upon x when x tends to 0. So what is the format of this? When x tends to 0, this becomes log 1. Log 1 is 0. When you replace x by here, is 0. So it is 0 by 0 form. So logarithmic function is present, and if it is 0 by 0, then you got to apply this formula. You can also do this by derivative method. You will get the same answer. So this is to be remembered. Now fast method. If I have limit x tending to 0, log of 1 plus kx upon x. Now what are the conditions for this formula to be applied? First term in the bracket should be 1. Second term should tend to 0. Second term and the denominator should be same. Second term and denominator should be same. So I do not have the same here. So I will divide and multiply with a k, multiplied with k into k. So this answer became 1, hence your answer is 1 into k and answer is k. So this is how we can go about it. So if you have a coefficient for x, directly you can write the answer as k itself. So limit x tending to 0, log of 1 minus 3x upon x. Directly your answer is minus 3. You don't have to calculate any upon etc. Whatever the coefficient of x, that will be answer. Limit x tending to 0, log of 2 plus 3x minus log of 2 minus 3x upon x. One method is we can apply the derivative method, but you can do this mentally. You can see that limit x tending to 0, I can write this as 2 common 1 plus 3x by 2 minus log of 2 common 1 minus 3x by 2. Now tell me, why did I take that 2 common? Because our formula is limit x tending to 0, log of 1 plus x upon x. This is our formula. So naturally, I need the first term to be 1, but I had 2 here. So I took a 2 common to make such a way that first term is 1. Now just have a look at this next step. This can be written as limit x tending to 0, log m into n, log m plus log n. Again here log 2 plus log 1 minus 3x by 2. And with that we are almost completed with it. Log 2 got cancelled. Now this became a formula. The coefficient is 3 by 2, hence answer is 3 by 2 here, minus, now coefficient here is minus 3 by 2, so minus 3 by 2, hence answer is minus 3 by 2 plus 3 by 2 will give you 3 as answer. So once again, log 2 and log 2 got cancelled. If you take this much as one formula and this much as another formula, the coefficient of x, if it is k is over here, then answer is k. So 3 by 2 is over here, so answer is 3 by 2. Minus 3 by 2 over here, so answer is minus 3 by 2. Already there is a minus sign here, so minus of minus plus, hence it becomes 3. So it's very easy to understand. But remember, if these two numbers are same, then only it will be of this format 0 by 0, otherwise they will not be of 0 by 0 form. Hence, we will find always the first number over here is the same. Then only this limit will work, and then only you will have a perfect answer. The limit is not tending to 0. So whenever the limit is not tending to 0, the best method is derivative method. So we'll differentiate the numerator, differentiate the denominator. So I can write limit x tending to 2, derivative of log x 1 by x, derivative of log 2 0, derivative of x 1, hence answer is 1 by 2. So very fast you can do. Whenever we have log, denominator is of degree 1, derivative method is an easy method to calculate. Summarize all the formulae that we have learned. First one, limit theta tending to 0, sin theta upon theta is 1. If k, there is a coefficient for theta, then answer is that coefficient k. 1 minus cos k theta upon theta square, there will be k square by 2. Tan k theta upon theta is k. What was the coefficient? That will be answer. A raised to x minus 1 upon x is log a. But if x is having a coefficient, be k log a, because a raised to k, it will become k log a. Then here 1 plus kx upon x, the coefficient of x is k here, so answer will be k. And finally e raised to kx. Just write this formula 2-3 times so that you remember the formula. Now they can ask you a combination problem like this. First you have to check whether degrees are equal. Now sin kx upon x will make a formula, upon x square will make a formula, which means I require sin 4x upon x into 1 minus cos 3x upon x square, because you have seen is theta square, and here log of 1 plus 2x upon x is required, log also requires x. 5 raised to x minus 1 upon x is required. To apply this formula, x is required. Tan 2x upon x is required to make it into this formula. And all of them should have limit x tending to 0. All of them have limit x tending to 0. Now you can write your answer directly. This is something but 4. This is nothing but 3 square, k square by 2. So 3 square by 2 divided by log of 1 plus kx, coefficient of x is k here, coefficient of x here 2, log 5 into 2. This becomes your answer. Now wherever we can cancel it. So 9 by 2 log 5 becomes your final answer. So this way, all the formulas together can be asked as a single term. Here derivative methods will not work. So you need to know the formula to apply this combination problems. They can ask you any n number of combination problems. You'll have to write the answer directly by remembering this formulae. So please write down this formulae 2-3 times and learn it. And that's the last part of limits formulae.